All right, so we're doing 3-5 systems and 3 variables. This is part 1. It's focused on elimination. And then we'll have part 2, which is focused on using substitution method. But for part 1, we are focused on the elimination method. So types of solution. Because we have 3 variables, that means we're working with planes, not just lines. So if you remember from geometry, a plane. And so we're looking at what points do these planes intersect, okay? So if you look, we have no solution in these 3 situations, okay? No point lies in all 3 planes, so there would be no solution. We're looking at one solution if it's this type of situation, and it's right there, where they all meet, where they all come together. And then we're looking here at infinite solution, because they all have a common line. Instead of just a common point, they actually have a common line. So those are our types of solutions for 3 variables. And again, 3 variables means that we're working with a plane, not just x and y. So for 3 variables, we're working with x, comma, y, comma, z. That's what our 3 variables are. All right, so steps to solve by elimination. 1, we're going to write all the equations in standard form, cleared of decimals or fractions. So standard form means we're writing in ax plus by plus cz equals d. That's just the gist of it. X plus y plus z equals a constant, okay? We want to label the equations. So there's 3 of them typically. So we're going to label them 1, 2, 3. And we're going to choose a variable to eliminate. And then we're going to choose any of the 2, 3 equations and eliminate the chosen variable. And then we're going to repeat that again and choose a different set of 2 equations and eliminate the same variable. And then we're going to solve the 2 equations that we got from, oh, I forgot to change my numbers, from steps 3 and 4 for the 2 variables they contain. And then substitute the answers from step, I thought I changed these, step 5 into any equation involving the remaining variable, okay? So it's a little bit of a process, but again, I think it's a fun process, okay? So the best way to learn is to dive in, and we're going to dive in. So here's our problem. So we have 2x minus y plus z equals 4, x plus 3y minus z equals 11, 4x plus y minus z equals 14, okay? They're all in standard form, so step 1 is good to go. Step 2 is to label them. So we're going to call this 1, 2, 3, okay? Step 3 is to decide which variable do you want to eliminate. Well, looking at this, the easiest variable for us to eliminate will probably be z right now, okay? So we're going to eliminate z. So to eliminate z, we're going to choose 2 equations at a time to work elimination with. So let's do 1 and 2. Why 1 and 2? Because our z's are going to go away fairly quickly if we do 1 and 2. So we're going to use 1 and 2. So we have 2x minus y plus z equals 4. And then we have x plus 3y minus z equals 11. We're going to combine. Our z's are going to cancel out. And we're left with 3x plus 2y equals 15. Okay? And then now, we're going to do this again, but we're going to choose a different set of equations. So we did 1 and 2. Now we could do 1 and 3. So we're going to do it with 1 and 3. So 1 and 3, we're using 2x minus y plus z equals 4. And then we have 4x plus y minus z equals 14. And again, our z's are going to cancel out. We're left with 6x, and what happens here? Our y's also cancel out. Equals 4, and 14 makes 18. Okay? We could actually solve for x here. So we're going to divide by 6, and we get x equals 3. So we're going to use what we got from the blue and the red together. So since I know what x is, I can plug x in and solve for y. So I'm going to plug x in. So we have 3 times 3 plus 2y equals 15. That gives me 9 plus 2y equals 15. We're going to subtract 9. That gives us 2y equals 6. We can divide by 2. And that gives us y equals 3. So now we have our y, we have our x. So the last thing we have to do is just choose any of our equations that from the original to solve for z. So it doesn't matter which one you use, you're just solving for z. I'm going to plug into number 1. So into number 1, I'm going to plug in y and x. So I'm going to be using 2x minus y plus z equals 4. I'm going to substitute x in, and I'm going to substitute y in. That gives me 2 times 3 minus 3 plus z equals 4. 6 minus 3 plus z equals 4. 3 plus z equals 4. I'm going to subtract 3. Z equals 1. So therefore my solution is 3, 3, 1. And again, because this is equations, if I'm not sure about my solution, I can take 3, 3, 1 and plug it into the equations to make sure that they all check out. So if I got 3, 3, 1, I can plug it in here. 3 times 2 is 6. So this is the checking ourselves. So we have 2 times 3 minus 3 plus 1. This gives me 6 minus 3 plus 1. This gives me 3 plus 1, which equals 4, and that's what I needed to equal. I can check the next one. So plugging into, so this was plugged into equation 1. We're going to plug into equation 2. And I have 3 plus 3 times 3 minus 1. And what does that equal? So multiplication first. So 3 plus 9 minus 1. And then 12 minus 1. And that gives me 11. And that's what I needed. And I can check equation 3. And that gives me 4 times 3 plus 3 minus 1. That gives me 12 plus 3 minus 1. That gives me 15 minus 1, which equals 14. So I know that I did it right. Okay, how do we feel? All right, our example 2. And this time I'm going to do a better job of numbering the steps. I apologize on the last one. Okay, so step 1 is you're checking that it's in standard form. So step 1, standard form. Every XYZ, XYZ, XYZ. Okay. Step 2 is you're going to label each 1, 2, 3, labeled. Okay. Step 3 is you're going to choose a variable to eliminate and combine those and combine 1, 2, or 3 together to eliminate that variable, or and then do it again. So step 3. So when I look here, I have a negative and positive y's. So a giveaway for a variable to eliminate would be my y's. So looking at my y's, I'm like, these are good ideas to eliminate. So the first 2 that I'm going to add together 1 and 2. So I'm going to add 1 and 2 together. Erase this circle around this. I'm going to add 1 and 2 together, and that's going to have x minus y plus z equals -1. And that gives me x plus y plus 3z equals -3. And it gives me 2x, and my y's are going away like I planned, plus 4z equals -4. Okay? Step 4, I'm going to do the same thing, but with 2 different equations. So step 4, choose the other 2. So this time I'm going to do 2 plus 3. So I'm going to add 2 and 3 together. So adding 2 and 3 together, I have x plus y plus 3z equals -3. And I have 2x minus y plus 2z equals 0. Just as I hoped for. And I get 3x plus 5z equals -3. All right, so this time we were not as lucky for a second variable to eliminate. And so because we're not that lucky, we're going to go on to step 5. And with step 5, we're just going to use our previous learned elimination skills to work with linear. So this is just linear now because it's only 2 variables. So step 5, we have 2x plus 4z equals -4. We have 3x plus 5z equals -3. And I need to eliminate one of these variables. So previously when we talked about elimination, you're going to choose a variable, find the least common multiple, and go from there. So I'm going to do x's, they're right there, and my least common multiple of 2 and 3 is going to be 6. So I'm going to have to multiply everything here by 3, and I'm going to have to multiply everything in the second equation. I'm going to multiply by -2 so that I can ensure that my x's will cancel out. Okay, so this is going to lead me to 6x plus 12z equals -12. And then I have -6x minus 10z equals +6. They eliminate just as I planned. And I get 2z equals -6, divide by 2, and therefore z equals -3. So I have one variable. So just like when we talked about linears, once you have one variable, you take it and you plug it back into one of the originals. So I'm going to take z and plug it back into back into either 2x plus 4z equals -4 or 3x plus 5z equals -3. It does not matter which one I plug it back into so that I can solve for x. So I'm going to go with 2x plus 4z. Right above. So 2x plus 4, and instead of z, I'm putting -3 equals -4. So that gives me 2x minus 12 equals -4. Add 12 to both sides, and I get 2x equals 8. So x has to equal 4. So now I have my x. And the last and final step is to take that value So step 6 is I'm going to take the two variables I've solved for and plug back into one of the originals. I'm going to use the first one, x minus y plus z equals -1. So x is 4, z is -3, and it equals -1. 4 and -3 makes 1, so I have 1 minus y equals -1. I'm going to subtract 1 from both sides, and that leaves me with -y equals -2. Multiply both sides by positive, So y equals 2. So my solution is parentheses 4, comma 2, comma negative 3. Okay, how are we feeling? No questions? Okay. Then we have one more example.